First of all, notice when going backwards and finding the integral of that inside function that you would have had a simple chain rule. Had you done the derivative, the chain rule would say multiply by 2 afterwards. So we have this additional divide by 2. It's your regular power rule where we added 1 to the exponent and divided by our exponent. But because there would have been a chain rule that multiplied by 2 when you did the derivative, in the integral, we have to divide by 2. So first part of the definite integral is work backwards from the derivative, find out what the integral would have been, put it in square brackets with your bounds, and then plug in your bounds, plug in the 2, the top one, minus plug in the 3, the number on the bottom. So had we done this same integral from 2 to 3, the answer would have been positive 0.2. But because we did the integral from 3 to 2, we get a negative 0.2. And I'll scroll down here. Or maybe I'll just change the view so you still can see everything, but you can see the graph as well of the area that you were figuring out. So normally, had you gone from 2 to 3, you can see that all of the shaded area is positive. So going from 2 to 3, that accumulation of change would have been a positive 0.2. Now you're looking backwards, saying, oh, I was at 3. What would I have to do to go back to my weight when I was 3 years old or whatever? I'd have to lose a lot of weight, and that would be negative as a result. So again, step 1, draw some square brackets and integrate the inside, but don't need to do the plus c because we have a definite integral. So the x will be x squared over 2. Now e to the negative x would be e to the negative x divided by a negative 1. So I put the negative in front with the negative on the bottom and made it plus right away. But sometimes sometimes writing it like that just makes us see it better. Because that e to the negative x would have had a chain rule where we multiply by a negative 1. So to compensate in integration, we'd have to divide by that negative 1. But sometimes skipping that little step and like, why did we change that to positive? Gets confusing when you look at your notes later on. Then plug in 0, plug in negative 2. And you could have left this as negative 1 minus e squared. We get an answer of negative 8.39. If we look at this graphically, the entire shaded area is below the x-axis. Every time the area is below the x-axis, that represents a negative change.